Beta, what are we supposed to discuss today? Yes, I can hear you.
Ma'am, can you send some JEE sample question papers with solutions, ma'am? Previous year's question papers.
You want me to discuss previous year questions? Okay, just wait. I'll download a paper and then we will discuss that.
Ma'am, do you know any website where we get sample question papers, ma'am?
Sample question papers will be available on NTA website only. But if I talk about some previous year questions that you will find on Toppers Learning website as well. Just 1 second. So let's discuss. See, we can use advanced paper because some advanced question come from there. Or you want particularly JEE mains paper only?
Ma'am, JEE mains.
Okay, just wait.
Yes.
Have you completed a practice for JEE mains 2020?
Ma'am?
Okay, I'm just uploading the question paper. Okay, so here we have physics is going on. Let's go for chemistry. Just wait a second. Just wait a second. Okay, I'll be back in 1 minute. Just let me try it.
Class is full.
Beta, just 1 minute.
Yes, ma'am.
No, sample question papers are not same for both. We will just discuss the question paper for 2019. You'll have to wait for 2 minutes.
Yes, ma'am.
Can you see the question paper?
Yes, ma'am.
Okay, just 1 second. Try these questions. First of all, try question number 31 and 32. क्या हुआ अच्युता? You can speak as well.
Yes, ma'am. Ma'am, can you send these question papers with solutions later, ma'am? I'll be able to practice.
Okay, so now can we move further?
Ma'am?
Right now, can we move further in that case?
Okay.
Okay, how much have we already completed?
I didn't do the chemistry part, ma'am.
Beta, in previous class, how much have we completed?
We were doing the organic chemistry, ma'am.
In that, organic chemistry was being done in doubt class. Before that, in regular class, periodic classification was over.
Yes, ma'am.
Chemical bonding,
Yes, ma'am.
it was completed.
Yes, ma'am.
Okay, so let's start with states of matter. Okay. So the topic of the day is states of matter. If I talk about states of matter, then the amount of, if I talk about states of matter, then there are basically three states of matter: solid, liquid, gas. Fine. In this chapter, we will study about gaseous state. In gaseous state, we have different laws that pressure is inversely proportional to volume, pressure is directly proportional to temperature, pressure is directly proportional to number of moles, volume is directly proportional to temperature, volume is directly proportional to number of moles, then temperature is inversely proportional to number of moles, and so on. So consolidated ideal gas law is PV upon NT is equal P1 V1 upon N1 T1 is equal to P2 V2 upon N2 T2, which is equal to R basic. Do you understand this?
Yes, ma'am.
After this, in this very part comes Dalton's law of partial pressure. If I talk about Dalton's law of partial pressure, it states that the partial pressure of each gas is in the ratio of their number of moles. Basically, it says that total pressure is equal to P1 plus P2 plus P3 and so on, which is also equal to N1 T upon N1 RT upon V plus N2 RT upon V plus N3 RT upon V and so on. Do you understand this?
Yes, ma'am.
So this was Dalton's law of partial pressure. So if I'm saying I have a gas A with having 5 moles and gas B having 10 moles and the total pressure is say 30 atmosphere. What will be the partial pressure of A and B? What will be the partial pressure of A and B? See, can I say the total pressure 30 is equal to pressure of A plus pressure of B equal to 30? Yes or no? Yes or no? Ajita, please unmute your mic. The total pressure 30 is equal to pressure of A plus pressure of B. Also, can I say that pressure of A is equal to number of moles of A upon number of moles of A plus B into total pressure, which is equal to 5 upon 15 into 30. 15 ones are 2s are 10 moles. If I talk about pressure of B, it is equal to number of moles of B divided by number of moles of A plus number of moles of B into total pressure, 30. Ones are, twos are. Answer is 20 at most. Understood? Understood, beta? Any doubt? Okay. So, this was about gas laws, ideal gas equation, and Dalton's law of partial pressure. Before moving towards kinetic theory of gases, I will give you a few questions. Is it fine with you? Achita? Achita? Ajita, please speak up, Ajita. Okay, I'm moving further in that case. Then we have kinetic theory of gases. Kinetic theory of gases. If I talk about kinetic theory of gases, then we have different speeds. Fine. We are going in short. Basically, first of all, we have root mean square speed. Root mean square speed, which is equal to v1 square plus v2 square plus v3 square till vn square divided by 2 under root. No, sorry, not 2, n. Fine. Then we have average speed. Average speed is equal to, and this can also be written as under root. Under root, what can this be written? Ajita, please speak up. 3RT by M. And then we have average speed. Average speed is V1 plus V2 plus V3 till Vn divided by N. This is equal to under root 8RT by pi M. Then we have most probable speed. Most probable speed. This is equal to under root 2 RT by M. Please note this down. Note it down. After this, we have Graham's law of diffusion and effusion. Graham's law of diffusion and effusion. What is the difference between diffusion and effusion? In diffusion, one goes from one container to other container, and on the other side, one goes out of the hole to the whole atmosphere. So basically, R1. Suppose there are two gases in the container, and if I talk about speed or rate of diffusion, then R1 upon R2 is equal to under root M2 upon M1. Fine, just note this down. Ajita? No, beta, I was not getting text from you. Okay. So I'm going to give you questions related to this now. Okay, try these questions. Okay, Ajita, try these questions. Beta, keep answering when you are solving. Okay, I'll just do the first one. 16 gram of O2 was filled in a container of capacity 8.21 liter at 300 Kelvin. Calculate pressure exerted by oxygen. Okay, so 16 gram O2. See, you have mass of O2, so can you calculate number of moles of O2? That is half mole. You have volume, you have temperature. Can you calculate the pressure? How? Pressure into volume is 8.21 equal to number of moles. Number of moles are half into R 0.0821 and temperature 300. So from here, can you calculate calculate the pressure? How come? Pressure you have to calculate. You have volume 8.21, number of moles half, are 0.0821 into 300. 0.0821 can be written as 8.21 upon 100. 8.21, 8.21 cancel, 100 cancel. Answer is 1.5 atmosphere. Understood? Understood, beta? सेकंड का 0.5 जल्दी जल्दी सॉल्व करो। एट्थ का फर्स्ट पार्ट का तो आंसर है 1.5 जैसा कि हम निकाल चुके हैं। सेकंड पार्ट का आंसर है O2 का कितना होगा 0.75 और O3 का 0.5। O2 का 0.75, O3 का 0.5 और थर्ड का आंसर क्या हो जाएगा 0.208। एटमॉस्फेयर हो जाएगा। यस बेटा, आई हैव बीन टेलिंग यू द आंसर्स। Let me just refresh. For second one, for oxygen it is 0.75, for ozone it is 0.5. Okay, I'll just do it for you, Achita. Suppose, see, partial pressure of O2 and O3, if oxygen is 50% oxygen is converted into ozone at same temperature, right? So, suppose we have oxygen and it is converted into O3. So, I can say it would be, conversion would be in such a way that it will be 2 by 3, right? So, oxygen, if this was 0.5, half of it has been dissociated. 0.25 is left. How much is being made? 2 by 3 into 0.25. So it is 0.5 upon 3. So if I talk about partial pressure of O2, then it is pressure into 8.21 liter, volume would be same, is equal to 0.25 into 0.0821 into 300, which is equal to 0.25 into 8.21 into 3. Pressure into 8.21. So 8.21 cancel. So pressure is equal to 0.75 atmosphere. Now if I talk about volume, ozone, in case of O3, then we have pressure, we have to calculate 8.21 equal to 0.5 upon 3 into 0.0821 into 300, which is equal to 0.5 upon 3 into 8.21 into 3. So 3 cancel, 8.21 cancel. So pressure will be equal to 0.5 atmosphere. Understood, Ajita? Ajita, am I audible? Have you understood? Okay. Do the next question. Do question number 9. Okay. One point six. Let me check. No, beta. You are telling me the answer for question number 9. No, it was not correct. I know what mistake you have done. You have taken this 27 degrees Celsius as Kelvin. 27 degrees Celsius means 300 Kelvin. Make sure. Correct. Very good. Do for question number 10. Okay, I'll do the 10th one. 1 into 10 raised to the power minus 2 kg of hydrogen and 6.4 into 10 raised to the power minus 2 kg of oxygen are contained in a itne meter cube flask at 473 Kelvin. Calculate the total pressure of the mixture. If a spark ignites the mixture, what will be the final pressure? Okay. See, they have given you mass of hydrogen, mass of oxygen, fine, and volume. So from here, can you calculate number of moles? 10 की power minus 2 into 10 की power minus 3 upon 1, 2, sorry. Similarly, you can calculate the number of moles of oxygen. Yes or no, Ajita? Now, since you have calculated the number of moles of hydrogen and oxygen, 10 into 10 की power minus 3 meter cube. Can you convert this into liters, decimeter cube? Yes. How come? 10 into 10 की power minus 3. This was given, no? Yes. So can I say this will be divided by into 10 raised to the power minus 3, nahin, into 10 raised to the power 3 liters. So 10 liter basically. You have number of moles, you have volume, and you have temperature. Can you calculate the pressure? Can you calculate the pressure? Ajita, please try and calculate. Am I audible? Done? Done, Ajita? Ajita? Am I audible, Ajita? Okay.
How are you all? कैसे सब लोग? जी, मारुति, how are you?
19.6. Let me check. बेटा फाइनल प्रेशर 19.6 एटमॉस्फेयर होगा, करेक्ट? इसके बाद नेक्स्ट क्वेश्चन नंबर 11 करो.
In the last class, we had started this.
क्वेश्चन नंबर 11 करो.
Okay. What is the question? What question to Abhishek? Harshvardhan सबसे पहले was following the religion. It's a religion that was a Shivite. Okay, and after Shivite death, he converted to Buddhism, also Buddhism. India, and after India, Maya. So first he was a Shivite, then he got converted into Jainism. after DRS, we got converted to Mahayans. Shivangi? Two SMEs. Two SMEs that I think which were being read.
Tell me when you have done.
Out of these two assemblies, what's the assembly name? What is okay? Which of these assemblies are my words? Okay.
Pressure difference is 3. Let me check. No, beta. Pressure difference is not 3. Yes, lead will stay on the container, that is correct, but pressure difference is more than 3. Tell me what?
What was the name of foreigner who came to Russia? What we are talking about after the Gupta's empire did what was the result? So many feudatories, group of feudatories. And remember, what is feudalism? Feudalism, what is feudalism? What is feudalism?
No, beta, answer is 6. Try again. See. 1 mole of NH4Cl is kept in an open container and then covered with a lid. The container is now heated up to 600 Kelvin, where NH4Cl completely dissociates into NH3 and HCl. If volume of the container is 24.63 liters, calculate what will be the final pressure of gases inside the container. Also find the lid would stay or bounce off if it can withstand a pressure difference of 5.5. Assume that outside air is at 300 Kelvin and 1 atmosphere pressure. Fine. तो अब आ जाते हैं NH4Cl पे. NH4Cl solid. It will give NH4 plus NH3 gaseous plus HCl gaseous. 1 mole plus 1 mole. If this is 1 mole, it will dissociate into 2 moles. Now pressure, you need to calculate volume is 24.63, number of moles are 2, R is 24.63 upon 300 into 600. So 300 ones are 2s are cancelled. So pressure is equal to, one second. Pressure into 24.63 equal to 2 into 24.63 upon 300 into 600. Answer should be 4 atmosphere. So the answer should be 4 atmosphere. Pressure is equal to 4 atmosphere. So pressure difference is equal to 3 atmosphere. Something is missing. Covered with a lid. See, 1 mole of NH4Cl is there, and also 24.63 liter of air is also there. Yes or no? Ajita? It was an open container. Then it was covered with the lid. So can I say that 1 mole of air was also there? Not 1 mole exactly, 24.63 liters. Fine. Which was having pressure 1 atmosphere. So first of all, I need to calculate the number of moles of this air or gas or whatever. So it will be equal to pressure 1, volume 24.63, number of moles you need to calculate are 24.63 upon 300 into 300. Vanza. So number of moles equal to 1. Okay, so number of moles will be equal to 3 now. 2 plus 1, 3. For the final pressure. So this will be equal to 6 atmosphere. And pressure difference can be 5.5. So you can go up to 6.5. So the answer will be 6 atmosphere. The mistake you did was, did you get it or should I explain again, Ajita? It was a good question. Should I explain again or you have got it? Ajita? Ajita, am I audible? Did you get the question or should I explain again? Ajita, am I audible? Ajita, am I audible?
The invention rights, the judicial rights of mutual power, in addition to the land, these are the things that are also given to the land. Take example, person is getting, like this is the land, and this land,
No issues. Have you understood or should I explain this again? Okay, I'll just explain again. The basic thing is see this was a container. There was a lid on this. We had NH4Cl plus air. So can I say we had combination 1 mole of air? Because temperature was 300 Kelvin and pressure was 1 atmosphere, 24.63 liter container was there. So there was 1 mole of air. Now we have pressure NH4Cl. It will convert itself into NH3 plus HCl. If this was 1 mole, so can I say it will dissociate into 1 plus 1 mole? So how many moles in all are there? 3. R 24.63 upon 300 into 300, which is equal to pressure T into volume 24.63. So can I say 24.63.63 cancel? This was 600, sorry. 300 ones are 2s are. Pressure is equal to 6 atmosphere. Understood, Ajita? Just note this down. Okay. Start doing question number 12.
And when we are going to that, it's have you heard of the they were online. So when I was like in Delhi, when I was preparing, so when it happens to be when you're preparing, you're slightly depressed. every day, oh my God, we get every day. But yes, for me also, like sometimes directly do any other content. Like, no Google City. But then, like, no Google City. So, I don't know what I was doing. What I was doing was, I was having that. I was having that. And still, one pair of shoes, then a diet, and it's very time there. What is the time? Okay, it is 3 p.m. It is 3 p.m. So the main Kashmiri is very famous. So Kashmiri is no like Haryana road is एक बस होती है from Delhi direct Delhi to Katra stand for 4 p.m. Board this bus from Delhi to Katra. The next morning, the bus will be reaching at 6 a.m. Morning bus. And this bus is a simple bus, not only simple bus, a simple government bus. Simple government bus after reaching there, वहाँ पे जाओ, वहाँ पे like जो public conveyances होते हैं, use that, and after using that, then follow to that place, 13 kilometers. Have a look at the green, the hills, the river, that Mandala river, and Mazilo Shivangi, enjoy that place, have darshan also, and then the same bus which had like 6 o'clock, the same bus which starts very early at 2 o'clock.
For helium, it's 0.246. Let me check.
The same bus, next day 5 a.m. 2 nights in the bus.
Yes, correct.
This was something that I did so many times. For training, you need planning.
No. For
this is something that we
for oxygen, it would be, I guess, 0.492 atmosphere. Just check this. Try question number 13. Answer is 0.246 and 0.492. You must have done some silly mistake.
When we have these two books, there are some points. Actually, the number of points of the ranks of Pasha is less. Now, why the number of points is less? Now, the reason is that
Yes, correct, Ajita. Total pressure is 0.492 and one partial pressure is given, that is 0.246. Correct. Start answering question number 13.
Just think, you're doing some job. If you're doing some jobs, you are getting something easy. If you are doing that job and the person says, okay, this job, I will not pay you this money, I will pay you that. I will pay you that.
Okay, I have just explained. I'll explain it again. See, calculate relative rate of effusion of SO2 to CH4 under given condition. See, I told you that R1 upon R2 is equal to under root M2 upon M1. In case of similar temperature, or we can say n1 upon n2 into under root m2 upon m1. In this case, under similar condition of pressure and temperature, then we have RSO2 upon RCH4. It is equal to under root of 16 divided by 32 plus 32, 64. 1 4 so it is 1 upon 2. Do you understand, Ajita? So answer is 1 by 2. Through a container containing SO2 and CH4 in 3:2 mass ratio. Fine. So basically this would be equal to RSO2 upon RCH4 is equal to under root NSO2 into RT upon MSO2 divided by NO2 into RT upon MCH4. So RT cancel. Number of moles of SO2. Let's assume we have 3 gram of SO2 and 2. Sorry. Okay. So, just 1 second. Okay, so through a container containing SO2 and CH4, let's have 3 gram SO2 and 2 gram CH4. So it would be somewhat like this: 3 upon 64 divided by mass of SO2 64 divided by 2 upon 16 into 1 upon 16. So 16 ones are 4s are 16 ones are 4s are. So this will be equal to 3 upon 4 into 1 by 4 into 1 by 2. So answer will be 1 upon 4 under root 3 by 2. Okay. Now you can solve. So basically the concept is that rate of effusion, the ratio of rates of diffusion and effusion will be inversely proportional to their molar masses, and also they would be somewhat nRT upon M. They would be directly proportional to nRT upon M. Understood, Ajita? Ajita, have you understood? Okay.
What is this self-sufficient villages? क्या है self-sufficient villages? Maruti, what is this self-sufficient villages? Or village economy? Yes, Maruti, you can tell me.
Start doing question number third part.
What is this self-sufficient villages? It means that the production will be there. Who is doing this agricultural production? It is company there. This is happening. What will happen? The production.
Done third part. You tell me the answer, beta. The answer is half, 1/2. Acha, there is some error in the previous one. I'm sorry. It is basically N1 upon N2 comes outside. So there is an error. NSO2 upon NCH4 under root M2 upon M1. So this would be NSO2 3 upon 16, 3 upon 64 divided by 2 upon 16 into 16 upon 64. 1 za, 4 za. 2 1 za, 8 za, 8 1 za, 4 za. So 3 upon 16. Fine? Fine, Ajita? Chalo. That is all for the day. We will continue with this in the next lecture. In next lecture, we will study about real gases, okay? And compressibility factor. Chalo. Bye-bye. Have a nice day. Okay, bye-bye.